Welcome to Lahari tutorial for colorful chemistry. Yes, today we shall discuss about a nomenclature of coordination compounds. According to the IUPAC, that is International Union of Pure and Applied Chemistry. Here there are some rules for naming the coordination complexes. The first one is the order of naming ions. In ionic coordination complexes, the cation is named first. So, in a coordination complexes, first we have to name the cation. It may be in a complex ion or a simple ion. For example, KCl. KCl is the simple salt. The name of KCl is potassium chloride. So, similarly, consider a complex compound K4FeCN6. So, this is one of the complex compound. So, here also the name of this complex is potassium hexacyanoferrate. So, here also we are considering the name potassium. So, whether it is a simple salt or a complex salt, first we have to name the cation. Okay, the second rule is naming of the ligands. Naming of the ligands. The names of negative ligand end with the suffix O and positive ligands end with the IUM, and the neutral ligands are named as such a molecule. Here the ligands are classified on basis of their charges. See here, for example, this chlorine, bromine, iodine or fluorine or the cyano. So chlorine, this is one of a negative ligands, means all these are negative ligands. It must end with the suffix O, so that we can call it as a chlorido, bromido, iodo, fluorido and a cyano. So similarly, NO2. NO2 is a nitro group. It is one of a positive ligand. Here NO2 is nitro. It is positive ligand, so that it must end with the suffix IUM, so that nitronium ion. Nitronium ion. Similarly, there are neutral ligands present. NH3, it is ammonia. So the neutral ligands named as such a molecule, so that it is itself called as a ammonia. Similarly, CO. CO is a carbonyl, and H2O. H2O is one of a neutral ligand, that is called as aqua. So based on their charges, the ligand must be ends with the suffix O and IUM. Okay, clear? The third one, order of naming the ligands. Yes, if the ligands are named in a alphabetical order, irrespective of their being neutral, negatively and positively charged. Here the complex may containing two or more ligands. You can see here this complex containing 3 ligands. Here the platinum is a central metal, 1, 2 and 3 ligands. Okay, this complex, the cationic complex containing 3 ligands. The first one is chlorido, and it is a nitronium, and this is the ammonia. So here the first letter ammonia is A, and this is N, and this is the C. So here first we have to consider which ligand? The ammonia, because the first alphabet is A. So tetra ammonia chlorido nitronium. Okay, so with respective their names we have to take a consider in order of their ligands. Next, the oxidation. The fourth rule is oxidation state of the metal in cation, anion or a neutral coordination entity is indicated by a Roman numericals in parentheses. So here the oxidation state of a metal, it may be in a cation, anion or a neutral coordination complex. And so for example here the metal is silver. So we have to calculate the oxidation state of this metal. So for that let us consider this as a X plus how many ligands present here? 2. So what is the charge of the cyanide? That is -1. Now we require the charge on this sphere. Here the potassium has a +1 charge, so that the sphere has -1 charge. Here equal to -1. X minus 2 equal to -1. Then X equal to +1. So here the oxidation state of the silver is +1. So we have to write in a Roman numerical in a parenthesis. Okay. So the next example is this one. Here let us consider the central metal is cobalt. So we have to calculate the oxidation state of a cobalt. Let us consider it as X plus how many ligands present? 6. Here the ammonia is a neutral ligand, so that it has the charge 0. It's equal to, now this is considered as a counter ion, so that the charge is -3 and the charge on the sphere is +3. So here X plus 6 into 0 is equal to +3. Now X equal to +3. The charge on the central metal is +3. Okay, we can write it as in a Roman numeral. Yes. The next is ending the names. If the complex is cationic, the metal is named same as the element. If it is anion, the name of the metal ends with the suffix ate. Okay, here the ending the names of the complex. If the complex is cationic, the name of the metal is written as it is. Okay, if it is the anion, the name of the metal ends with the suffix ate. Okay, now let us solve this example. Here the potassium is positive, so the charge on the sphere becomes negative. Here there are 2 potassium, the charge will be +2 and here -2. So it becomes what? Negative complex. The name of this complex is potassium. So now go for this ligand. Which ligand is present here? Chlorido, tetra chlorido. The metal is mercury. Yes, here the complex is negative. Okay, the complex is negative, so that the name of central metal which ends with the suffix ate. Okay, so that mercurate. Yes, mercurate. What about the coordination? Sorry, what about the oxidation state? Here let us consider central metal X plus, so how many ligands present? 4 into Cl. The charge of the Cl is -1 is equal to charge on the sphere is -2. 2. So it becomes x minus 4 equal to minus 2. The value of x becomes plus 2. Here the charge on central metal is plus 2. So the oxidation state is 2. Yes, hope you understand the rules for naming a coordination complexes. So in next class we'll discuss about let us solve some problems. Thank you.